Okay, this is our video for more practice problems on day 3. We are given a bunch of identity statements. This left side equals this right side. And we are going to use our properties to simplify and show if this is actually true or not. And one new thing we're going to talk about today is this acronym QED. This is Latin for Quod Erat, E-R-A-T, Demonstrandum, Obliviate, just kidding. And it means which was to be demonstrated. We showed that which was to, or we demonstrated that which was to be demonstrated. Or, excuse me, it indicates completion, successful completion. So we're going to be writing that at the end of our proofs. These are proofs, just because that's a thing that is done in math, and so we're going to be mathematicians. All right, so looking at number 1, cosecant times tan times cosine, we want to know if that would simplify to 1. So we are just, have your chart out with the trig identities and the Pythagorean identities. And we're going to, first I want to identify something that can't be rewritten, and that's cosine. It's just cosine. But we can rewrite cosecant and tangent. So even if you don't have a really great idea about how you're going to simplify this entire problem, just start with the first step. Rewrite some things and then see where the math takes you. And you might figure it out or you might not. And if you don't, then you just have to make a new plan and try something else. And that is okay. So we're going to rewrite cosecant as 1 over sine times tangent, which we can rewrite as sine over cosine, and then times cosine. Now, since these are all being multiplied, we can cancel numerators and denominators that match. So this cosine is really over 1, so things that match numerator and denominator are sines and cosines. And then when we cancel things, remember they're really simplifying to 1, because anything divided by itself is 1. So we leave all these 1's behind, and when you multiply them all, you get 1. And is it true that 1 equals 1? Yes. All right, I want you to pause the video and try number 2 by yourself using that same approach. Rewrite your trig ratios and see if you can prove somehow that the left side equals the right side. Pause the video and do that now. Okay, this one does prove to be true, so here's how I solved it. I rewrote, so I have sine squared over 1 times secant, which is 1 over cosine, times cosecant, which is 1 over sine, and we want to know, does that equal tan? Now, I can write tan here, but I think I'm just going to go ahead and rewrite it and see if I can get the left side to look like this. So nothing cancels with the cosine, but if I have sine squared on top and 1 sine on the bottom, 1 sine cancels, because remember this sine squared means sine times sine. So one of those signs will cancel, leaving me 1 sine left on top. So now multiplying across my numerators and across my denominators, I have this, which is true. QED. Now looking at number 3, something that's different here from 1 and 2 is that there's an addition sign here. So chances are good that we may have to use one of these Pythagorean identities now, since these are the things with the pluses and the minuses. So we'll be on the lookout for anything that we can substitute with its equal expression from this chart. So I'm going to start by rewriting tan as sine over cosine, and rewriting cotan as cosine over sine. And then on this side, I'll rewrite cosecant and secant. And I could have rewritten cotangent as 1 over tan and tried to find common denominators. It just try something and see where it goes. This is not the only way to do this problem. Okay, but what I am going to do here on the left, since I'm adding two fractions, I want to make them have a common denominator. So I always think about making a group denominator that represents each individual one. So my common denominator would need to have a cosine to represent that one and a sine to represent this one. And so then my goal is to rewrite both of these fractions so that their denominators match this one. So this first fraction already has cosine. What it's missing is sine. So I'm going to multiply the bottom by sine and the top. This fraction is missing cosine in the denominator. So I'm going to multiply by cosine top and bottom. So I'm going to combine these into one fraction. Now that their denominators match, I combine them into one fraction with that denominator. I multiply these numerators together and then plus these numerators multiplied. So it's going to be sine squared plus cosine squared. And on the right, I'm going to multiply across the top and bottom, gives me 1 over sine times cosine. Now, this numerator, sine squared plus cosine squared, remember, that equals 1. And it doesn't matter that sine squared is written first, and on my formula sheet, it's written second, because the commutative property of addition says you can switch those around for addition, and it's going to be the same thing. So I can replace this entire expression with 1. So now I have this. And again, it doesn't matter in the denominators that cosine and sine are switched. That's my commutative property for multiplication. That says when multiplying, it doesn't matter the order. So we did, in fact, show that this statement was true, QED. All right, now I want to look at number 6. All right, here we have 1 plus sine times 1 minus sine equals cosine squared. So you may notice that this right here is difference of two squares. If you did, you could go straight to this form. This squared minus this squared. And then that would be 1 minus sine squared. And we know that that is equal to cosine squared. And you'd be done. Let's say you didn't recognize that. You could do this. You have a binomial times a binomial, and that is a FOIL situation. So first terms gives me 1 times 1. Outside terms minus sine. Inside terms plus sine. Last terms are positive times negative, so negative sine squared. Those signs in the middle cancel because they have opposite signs, and 1 minus sine squared does in fact equal cosine squared. So that was a simpler problem than it first appears. And then the last one I'm going to talk about is 8, and then the rest of the problems I'm going to leave you to try by yourself. You can find the key in your Google Classroom to check your work. All right, for this problem, I'm going to start by rewriting cotangent as 1 over tan. And then notice that this entire thing right here is squared. So the tan x plus cotan x is squared. So since it's squared, that means times itself. I'm going to leave the right side alone for just a minute and work on foiling this scenario. So distributing this tan to this tan gives me tan squared. Distributing this tan to 1 over tan, so I'm multiplying this by this. Tan on top, tan on bottom cancels out, leaving me 1. So I did this as tan squared, these two things multiplied, tans cancel. So now the insides do the same thing. 1 over tan times tan, those cancel, leaving me just 1. And then multiplying these together, multiply your numerators, multiply your denominators, gives me 1 over tan squared. Now this right here, tan squared plus 1, I have a Pythagorean identity for that. Tan squared plus 1 equals secant squared. So they can replace each other. So I'm going to replace that with secant squared. And then now I have 1 plus 1 over tan squared. Well, I can rewrite 1 over tan squared again as 1 plus cotan squared. And I have an identity for that. 1 plus cotan squared is equal to cosecant squared. So I'm going to replace those. Replace that with cosecant squared. And I have the secant squared from up front here, and that equals this right-hand side. I never even had to touch that right-hand side. And I just proved that they're equal. Okay, so the rest of the problems are there for you to finish and try by yourself for practice.